Okay, lecture 51. Know the definitions below here. What is the equation for kinetic energy? So we'll say KE is 1/2 mv squared. M is the mass of the object. V is the speed of the object. Let me get over to the right point in the book here. What is the kinetic energy in joules of a car weighing 1,253 kilograms and traveling at 51 kilometers per hour? Well, to get joules, remember what joules are: kilograms, meters squared per second squared. So we're in the right units for the mass, but for the speed, we're not. We need to have that to, changed into meters per second. So that's the first thing we got to do. So some chapter 1 stuff, actually. So kilometers, and then seconds, and this comes up to be 14.2. And actually, we have to change this to, and that's meters per second, so it's actually 14 meters per second. I don't think that's going to have too much of an effect, but I gave you 51 kilometers per hour, so it wasn't 51.0, so we have to go with this. And then our kinetic energy then is 1/2 the mass of the object, which is a car, and that's of the car is 1,253 kilograms. The speed is 14 meters per second. This is actually good to see when you leave off significant figures. You give a lower number of them, it actually makes things. I'm just going to, let's see, actually we have to round it even more. So it's no problem here. This is kilograms, meters squared per second squared. All it means is that we've lost a little bit of information. Actually, we never had it, so we couldn't put it in. So we have this as our answer. 2.5. I'm going to do this out again here, because I might have forgotten to take 1/2. Yes, I did. So this is actually incorrect. We got to divide by that 2. Remember, that's and it's dividing it in half, so it is important. So this is going to be 1.2 times 10 to the 5th joules. I was so obsessed with the fact that I only have 2 significant figures here that I forgot to divide by 2. 1.2 times 10 to the 5th, and that is the answer. Okay, now these units of energy, joules, are one of the most common, but we also have calories as well. And so 1 calorie is 4.184 joules, and that's exact. So if we have, if we want to convert, we have 167 joules, 4.184 joules, 1 calorie, and that's almost 4, so it's about a quarter. So that's a nice thing to keep. I mean, you want to get the right answer, get the correct answer, 39.9 calories. But when you get done, you should notice that your answer is about more or less a quarter of what you started with. This is about 160. Well, it's 167, almost 160. This is almost 40. That makes sense. Because this is slightly more than 4, this should be slightly less than 1/4, but let me do it out again just to make sure. But just something to keep in mind. You don't want to leave it as a guesstimation. That when I say that kind of thing where I say you want to guesstimate, that's as you're calculating, you want to have an idea of where you're going. So we have 328 joules. Again, this is about 8, so we'd expect our answer to be about 4 times more. It's 32.8. Yeah, that makes perfect sense. What is an equation for potential energy? Now, potential energy, I should say kinetic energy, has the equation of 1/2 mv squared. That's it. That's the only one that you're commonly going to come across. But potential energy, it depends on the potential energy. It's some object or something that's in a field, a potential field, gravitational field, electric field, magnetic field. There's also potential energy that comes from chemical systems. There's a lot of different equations. So when I say an equation, the one I meant here, and it'd be pointed out on in your class, would be the potential energy, PE, equals mgh. I'm trying to find it in the book here, make sure that it, yeah, okay, it's not prominent, but it's in there. So this is mass times the gravitational acceleration of the Earth times height. Height is in meters. Gravitational acceleration of the Earth is 9.81 meters per second squared. The mass has to be in kilograms, and then h is in meters, so that would give us total kilograms meters squared per second squared, which is joules. Our energy, even though we divide it up into different types of energy, energy is just energy, and it has to have the same units, joules, or it has to be something that can be converted back to joules at least. So determine the potential energy of a 5-gram pebble that is 16 meters off the ground, assuming that it's just been let go. 16 meters, so the height is 16 meters. The mass has to be in kilograms, so we have to convert over to that. And the gravitational acceleration of the Earth is a constant, you should know. My class, you'd need to know it. It's not too bad. It's one that comes up all the time in a lot of different science courses. So mgh is going to be 0.00500 kilograms. 9.81 meters per second squared. The height is 16.0 meters. And again, you want to carry the units through just to make sure that and this is 0.785 joules. I should say kilograms meters squared per second squared, and those are units of joules. I'm going to do this out real quick. 0.005 times 9.81 times 16. If you had forgotten to change this over to kilograms, when you got through, you'd have grams meters squared per second squared. If you do enough problems, that should stick out like a sore thumb and say, you want to convert over to joules, which are the units of energy that we'd want, and it would be pointed out on an exam problem. For my exam, I'd say I want it in joules or kilojoules. And you should recognize that as a problem. At least that would help you. If you leave the units off, that's when the problems start.